Hello friends, myself Vipul Patel. Welcome to my channel Smart Learning. In this session, we are going to discuss on current source inverter (CSI). The current source inverter converts the input direct current into an alternating current. In current source inverter, the input current remains constant, but this input current is adjustable. The current source inverter is also called as current fed inverter. The output voltage of inverter is independent of the load. The magnitude and nature of the load current depend on the nature of load impedance. In figure, you can see this current source inverter fed induction motor drive. In that, you can see the supply is DC and this combination of thyristor, capacitor and diode. With the help of that, the output means input current of induction motor is converted like this from DC. The diode D1 to D6 and capacitor C1 to C6 provide combination of thyristor T1 to T6 which are fired with a phase difference of 60 degree in the sequence of their number. It also shows the nature of the output current waveform. The inverter acts as a current source due to large inductance LD in this link. The fundamental component of motor phase current is shown in the figure. The torque is controlled by varying DC link current ID by changing the value of VD. When the supply is AC, control rectifier is connected between the supply and inverter. When the supply is DC, chopper is interposed between the supply and inverter. In the figure, you can see the current source inverter of DC motor drive. The major advantage of current source inverter is its reliability. In the case of current source inverter, a commutation failure in the same leg does not occur due to presence of large inductance LT. In an induction motor, the rise and fall of current are very fast. This rise and fall of current provide large motor spikes. Therefore, a motor of low leakage inductance is used. The commutation capacitance C1 to C6 reduce the voltage spike by reducing the rate of rising and fall of the current. A large value of capacitance is required to sufficiently reduce the voltage spikes. Now, the regenerative braking and multi-quadrant operation of CSI. When the motor speed is less than the synchronous speed, machine works as generator. The power flows from machine to DC link and DC link to and DC link voltage VD reverse. If a fully controlled converter is made to work as an inverter, then the power supply to DC link will be transferred to AC supply and a regenerative braking will take place. Hence, no additional equipment is required for regenerative braking of DC motor drive. The drive can have regenerative braking capability and 4-quadrant operation if a 2-quadrant chopper provides current in one direction but voltage in either direction is used. Now, the closed loop speed control of CSI drive. The closed loop CSI drive is shown in the next slide. The actual speed omega m is compared with the reference speed omega star m. The speed error is controlled through PI controller and sleep regulator. The sleep regulator sets a sleep speed command W omega star SL. The synchronous speed obtained by adding omega m and omega star SL determines the inverter frequency. Constant flux is obtained when the sleep speed omega SL and LS have the relationship. Since ID is proportional to IS according to the equation shown below, a similar relation exists between omega SL and ID for constant flux operation. In the diagram, you can see the closed loop sleep control CSI drive with regenerative braking. In that, you can see the different type of component like AC supply, fully controlled rectifier given to the inverter and inverter output given to the motor. This is the speed sensor, speed controller. This is the comparator. sleep regulator, flux controller, current controller, firing circuit, etc. Based on the value of omega star SL, the flux control flux produces a common reference current I star D, which through a closed loop current control adjusts the DC link current ID to maintain a constant flux. The limit imposed on the output of sleep regulator limits ID at inverter rating flux. Therefore, any correction in speed error is carried out at the maximum permissible inverter current and maximum available torque, giving a fast transient response and current protection. Thank you for watching this video.